Utah State University was founded in 1888 as an agricultural college. The mission has expanded over the years, but those agricultural roots and focuses have remained a fundamental part of USU. As a support to that focus, USU's Utah Water Research Laboratory, or UWRL, houses an indoor rainfall erosion control testing facility. The Rainfall Erosion Control Test Facility is used extensively to characterize the performance of erosion control products. The test facility can be adapted as needed to provide the most appropriate test conditions for the products being evaluated. The slope of the soil test beds can be varied from 0 to 60 degrees. Rainfall events can exceed 20 inches per hour, but 3 to 5 inches per hour is typical. The testing protocol and overall design of the test facility have been developed with reliable, repeatable, and quantifiable erosion control data acquisition in mind. Along the bottom of the boundary of the soil test beds, an expanded metal layer provides structural support to the soil column, and a layer of geotextile fabric retains the soil. The porous bottom boundary prevents water from ponding in the soil by allowing water to drain. The permeable boundary allows the 12-inch deep soil plots to simulate infinitely deep soil columns. The absence of an impervious bottom boundary reduces the risk of catastrophic mudslide failures caused by artificially retaining excessive water in the soil. Mudslides can also occur when a hard pan or less permeable layer is present in the soil column. To prevent this, the test bed preparation includes spading the soil column through its full depth and mixing the soil with a rototiller. Excess soil is removed through a screening process, and then the 20-foot long by 4-foot wide test plots, which contain sandy loam soil, are compacted to 70% standard Proctor density using a weighted roller. The soil is lightly raked in the transverse direction to break up the surface, and a nuclear soil density gauge is used to document the soil compaction. In the field, hydraulic mulches are applied based on pounds per acre using commercial-scale hydroseeders. A 70-gallon laboratory-scale hydroseeder is used at the UWRL to replicate this process. The hydroseeder is filled with 50 gallons of water, and the appropriate amount of mulch product is added per the manufacturer's mix ratio recommendation. The slurry is mixed for 5 minutes. The volume of slurry applied to each plot is determined based on the plot area and the application rate. The initial slurry volume in the hydroseeder is noted, and the amount of product applied to the test plots measured by tracking the volumetric change in the tank. A conscious effort is made to provide a uniform product application and to ensure good coverage at the toe of the plot. Following application, the hydraulic mulch products are allowed to dry for 48 hours. Prior to testing, the test plots are set to the prescribed slope, covered with plastic, and the Rainmaker is turned on and calibrated to the client-specified rainfall intensity. To calibrate the Rainmaker, the water runoff is collected for 2-minute periods, weighed and converted into rainfall rate. Incremental adjustments are made to the Rainmaker as needed. Once the target rainfall rate has been established, the plastic sheet is removed and the erosion control test is started. During the 60-minute erosion control test, all soil and water leaving the individual test plots are collected and segregated into 2 consecutive 30-minute collection periods. Every 15 minutes, a water quality sample is collected from the test plot runoff to quantify turbidity levels. The amount of kinetic energy in a raindrop is a function of the raindrop size. Natural rainstorms typically produce a raindrop size distribution ranging from 1 to 6 millimeters. The ability of a raindrop to damage a hydraulic mulch and soil surface increases with increasing raindrop kinetic energy. Raindrop kinetic energy is proportional to the diameter cubed and its velocity squared. The UWRL Rainmaker produces a uniform raindrop size of 4 millimeters. A 4 millimeter raindrop has 128 times the kinetic energy of a 1 millimeter raindrop. The goal in selecting the UWRL raindrop size was not to mimic a size distribution of a specific natural storm event, but rather to produce a uniformly sized, relatively large raindrop with enough kinetic energy to damage even the highest quality erosion control products. Having sufficient kinetic energy to damage the high-end products makes relative comparisons possible across the full spectrum of product quality. Following the erosion control test, the water and soil runoff quantities are measured and reported in terms of pounds per 30-minute period and for the full 60 minutes. The The results are compared with bare soil plots tested at the same slope and rainfall rate. The resulting C factor, which is the ratio of the soil runoff for the protected slope over the bare soil slope, is reported.